Welcome to R-2000, the Better Built House. My name's David Stringer, and I'm the host of this series of programs that are looking at the aspects of designing and building the Better Built House. So far, up to this point, we've been dealing with the broad issues involved in energy-efficient housing. And the kinds of things we've been seeing have been helpful to builders and interesting to ordinary mortals like myself. The next couple of programs are going to be a little bit different, though. We're going to be focusing directly on trades-related issues. See, an ordinary guy like me can take all the time and all the money in the world and build a fabulous structure. But to the builders out in the real world, there are some issues, like introducing new skills to the tradespeople and introducing different practices on the site. So we'll be talking in this program to some of the tradespeople who actually do the work. And I have to confess, I'm a little bit out of my league on the topic, but we have Oliver Drerup. He's an experienced builder of energy-efficient housing, and I'm going to let him take over. Only he doesn't know it yet. Hi, Oliver.
Hi, David.
You've been building energy-efficient housing for more than 10 years now, haven't you?
I guess I'm getting older.
I guess you are. I don't know why I'm not. But all throughout this, you keep stressing the quality aspects of this and the need to be involved with the people that work with you.
You bet. All builders have their own self-imposed standards, whether they're at building code or above building code, and the only way that you can achieve those standards is to work with the people on the site. I really believe that our company is building the best houses in the country, but the only way we can do that is to work very closely with our trades.
So to what extent do you change the way you do things to make the trades happy?
Particularly on a large development site like this one, for which we've just been looking at these prints, you have to change quite a number of things, but you have to change the sequencing even in a smaller project. You want to work very closely with the trades to figure out what the easiest way is for them to do the work, and that's what the show is about today. We're going to be looking at trades sequencing across sites, talking to some tradespeople. It's going to be fun.
It sounds like a great show. You don't mind if I stay a little bit in the background in this one, do you?
Well, as long as it doesn't ruin the program.
Well, I have some important research to do on passive solar gains, so have a good time, Ollie. I know you can handle things.
Hey, David? David? We've already done the program on passive solar gains, haven't we?
Canada is recognized as a world leader in energy-efficient construction. Innovative builders and researchers throughout the country have made some dramatic advancements over the last 10 years. Builders in particular have been encouraged to develop and try out a variety of new techniques and practices in the construction of their houses. And a good deal of this progress has been spurred on by government demonstration programs. R-2000 is one of these programs. The term R-2000 is a label representing a standard of housing that offers a maximum level of energy efficiency, high-quality construction, and exceptional comfort. The R-2000 home is recognized throughout North America as the Cadillac of energy-efficient quality housing. Any type of house can be built under the R-2000 program. The houses vary in size, shape, and construction techniques, but two things they all have in common are high standards of construction and energy efficiency. Each house is given an energy performance target determined by such things as local climate, house size, and the seasonal efficiency of the heating equipment. The builder runs all of the data on the house and the location into a computer program called Hot 2000. The computer simulates the heat loss characteristics of the house and even projects what the fuel bill should be. During construction, the house is inspected and tested. As long as the house meets the target established by the program, the house can be labeled as R-2000. Thus, when a house is given an R-2000 label, you can be sure that you're looking at a quality product.
There are no hard and fast rules for achieving high energy standards. In fact, builders like myself are encouraged to choose our own materials, construction techniques, mechanical equipment, and even house designs. We want to meet the needs of our clients. So there's a lot of leeway from both the design and the construction perspective. Despite all this flexibility, these houses have to meet an energy performance standard. What that means is that they have to fall within a certain framework. Now, when I say framework, what I mean is that there's something common to all R-2000 houses, certain features. Let's take a look at what those are. There are 5 key features common to R-2000 and other highly energy efficient houses. They have higher levels of insulation than conventionally built houses. They're built to control air leakage and to be draft-free. Because these houses are that much tighter, They require a mechanical ventilation system to provide a controlled and regular supply of fresh air to each and every room in the house. They use efficient heating equipment, and they make use of passive solar heat. These 5 characteristics represent a framework within which builders can design and build their houses so that they meet the R-2000 standard. Builders don't work in isolation. I think the vast majority of contractors probably got to be contractors after having first worked in the trades. I myself was a carpenter for 8 years. I'm very sensitive to the fact, as I think most builders are, that we are not doing the work ourselves. Our tradespeople do that work, and a very high level of cooperation is required if we're going to meet these standards. Now, there's a lot of work that's been done on a building site before we ever drive the first nail. I've gone out and worked with the client, with the architect, the designer, and made sure that we know what this process involves. We want to try and keep it as simple as possible because that makes it viable for us to get good supervision in the field. But while I'm out doing those things, I require a supervisor on the site who is first class, and I want you to meet this guy, JR. Can I interrupt you for a minute, JR?
How's it going, Oliver?
Pretty good. Good to see you. How are things on the site?
Couldn't be better. Everything's right on schedule.
Dynamite. And that, I suppose, is a key issue, making sure that things are scheduled properly from your perspective.
Yeah, if we get the schedule right, we make money.
Yeah, I know, on the good days. Listen, from your point of view, how are the trades taking this kind of construction method? I mean, do they find it difficult to get into this business, or?
Well, there's a little bit of increased supervision, but generally, if they're showing and the quality is stressed, they fit in well.
Do you find that there are any areas where there are particular difficulties in the scheduling?
Well, I think that the hardest thing for the trades is just getting used to the new scheduling. Now, with the R-2000 house, it requires, changes in the normal scheduling.
How about, for example, in a wrap and strap wall or where you've got hose bibs, electricians? I mean, these guys are coming in and out all the time, aren't they?
Well, that's correct, but with the additional supervision, the tradespeople are professional enough that once they're showing, they realize it's a quality product. They're looking for ways to aid the process.
Right. They're really not out there to sabotage you. They want to get it right.
That's right. They're interested in the uniqueness of the R-2000 home.
And what that is, what we're trying to achieve in these buildings is airtightness.
As we've seen, airtight construction is one of the key features of R-2000 houses. Airtightness is important in order to control the air leaking into and out of the house through the leaks and cracks in the building envelope. An effective air barrier will run continuously and without breaks through the building envelope. Commonly, the air barrier has doubled with the vapor barrier in the form of polyethylene sheeting. More recently, new air barrier systems employing structural elements of the house are being developed as an effective alternative. Airtightness of the building envelope eliminates drafts and makes the home far more comfortable. It also saves money because you don't have to pay for all the warm air that escapes and the cold air that comes into your house. Of equal importance, it helps to control the movement of moisture. Moisture control means two things. Interior humidity will be controlled, and concealed condensation in wall and attic cavities will not occur. And that's a boost to the homeowner, not only for comfort, but because it helps to preserve the structural integrity of the house.
Those are important considerations, Oliver, but perhaps we should tell the builders about the fan depressurization test.
Right on. Really, it's an extension of the entire supervisory role that both you and I have on the project, because it means that we can go out and actually find where there are leaks in the building, even after the building is complete. Well, the way we achieve that is by putting a blower door into the building and exaggerating the air leakage through any cracks or openings that are left in the structure, which we can then find with a smoke pencil. Now, I've got some footage that we took of tests being done in both R-2000 type houses and in more conventional homes, and I want to show them to you. Now, JR, when you see this kind of smoke movement, you know you're dealing with some pretty huge gaps. Heavy leakage like this is routinely found in conventional houses. Let's look at some of the weaker spots usually found in these buildings. Notice the amount of air leakage coming between the joints and the wood. And more leakage occurs around the baseboards, window frames, even through the cracks in poorly constructed windows. Really, at various locations throughout the entire building. Electrical outlets, plumbing stacks, the list goes on. And of course, all of this affects the trades.
Okay, what about an airtight house? Let's see a fan depressurization test on an R-2000 home.
That's quite a difference, isn't it? Well, as you know, JR, the construction techniques employed create an airtight seal. Any cracks or holes in the barrier caused by construction breaks or service penetrations are carefully sealed. The result is a highly efficient house that's almost 6 times tighter than a conventional building. And that means fewer drafts, lower fuel bills, and happier homeowners.
I agree with you, Oliver, but the practices for R-2000 housing are a little different than those for conventional housing.
Yeah, they are, and I think practices for other tradespeople are as well. What we want to do is go out and actually talk to the individuals who are doing this kind of work so that we can get a sense of what it's like to work on these projects from their point of view. And since you're not only a supervisor but also a framer, maybe we can start talking a little bit about framing.
Good enough. Well, in a conventional house, the framer builds his wall, the insulator comes in, insulates vapor barrier, that's it. You never see it again. But in the R-2000 home, the framer has to be concerned with the air tightness of the house, the continuous air barrier. Therefore, the framer is an integral part of that construction.
Well, I've learned a good deal from our host, David Stringer, and one of the things he's taught me is that he gets me to do all his work for him. I'm kind of thinking I'd like to get you to do some of mine. We've got a bunch of footage of various building details and some guys working on the site, and I wonder whether it would be possible for you to lead us through them.
I'd be glad to. Well, right here, we have 2 good examples of what may be required of the framers. You can see here, Oliver, how we've installed a strip of poly around the joist header. That'll allow for continuity of the air barrier from floor to floor. It means that the framers have to remember to install this strip of poly before the second floor joists are installed. There's also the entire issue of care to prevent the poly from ripping. I generally try to sandwich the material between the wall top plates. You can see here how we've installed the connecting strip between the top plates of this partition wall. Same concept of trying to keep the material away from damage. And you know, Oliver, how gently they move those roof trusses around.
Yeah, you bet I do. Listen, I can see that a lot of care and attention has gone into placing the vapor barrier tabs there. I know that for myself. Do you find that that screws up your production?
No, not really. It's just one more consideration for everyone to be aware of.
Okay. What about the other framing systems that we see, some of the more unique framing systems?
Well, that depends on which one we're using. First of all, we want to reduce the amount of wood being used, not only to keep costs down, but the more wood, the less insulation. By limiting the amount of wood, we also limit thermal bridging. That's where we'll see the value of insulated sheathing, strapped walls, double stud construction, and even some of the prefabricated wall sections. They all allow for the maximum amount of insulation with the least amount of thermal bridging.
Thanks a lot for your point of view, JR. I'm going to let you get back to work. I got to go. Time to wrap up the show, and I don't see David anywhere. I say. Oh! It seems that David is continuing his research into passive solar gain. Oh well. Next show, what we're going to be doing is continuing to look at the way in which trades integrate on the site. I hope you can join us. I hope David can join us.